Hello guys, and welcome back to the second portion of the double angle identities. For this video, we're going to have some examples for the application of the double angle identities. Let's proceed. Let's have example number 1. Simplify the following using double angle identities. Okay, so we have the given sine 2x over sine x minus cos 2x over cos x. So again, our goal is to simplify, or in this scenario, we're going to remove, okay, or not really remove, but to extract the identity of these double angle identities. Okay, so we have sine 2x, and we know from our previous video that sine 2x is 2 sine x cos x. Okay, all over. So let's just copy sine x. Then for cos 2x, okay, so since we're dealing with cosine, so probably we want to eliminate cosine, so we'll have to use cosine. Okay, the formula with the cosine, okay, is cosine squared. Okay, so 2 cosine squared x minus 1 all over cos x. Okay, so let's try to look if we can cancel out a factor. So here we have sine x, so cancel out sine x. Then we will have 2 cos x minus, so for this we can separate, so we'll have 2 cos squared x all over cos x. Take note, this is a minus sign, so this will be distributed here, so you will have plus 1 over cos x. Okay, so we can now cancel out cos x in the denominator, and here cancel out squared, so we will have 2 cos x, then we have plus 1 cos x. Okay, then we have 2 cos x minus 2 cos x plus 1 cos x. 2 cos x minus 2 cos x is simply, simply we have 0. Okay, this is 0. And we have 1 over cos x. So remember that 1 over cos x is, okay, so in our ratio identities, so we know that 1 over cos x is secant x. Hence, our final answer is secant x. Let's have example number 2. So we have 1 minus cos 2x over 2 sine x. So obviously this is double angle. Okay, so applying the double angle identity. Now, what double angle identity are we going to use? Take note, this is cosine 2x. Okay, so here's the clue. So most often times, our identity will depend on the given. Okay, so it happens that our given is 2 sine x. So I will be using the identity that contains sine x. Okay, specifically 2 sine x. Okay, so we will use 1 minus 2 sine squared x. Okay, I think this is the third form of the cos 2x identity. Okay, so this becomes all over 2 sine x. Okay, then let's simplify further. So we have 1 minus 1 plus 2 sine squared x all over 2 sine x. So we distribute the signs. Then 1 minus 1 is 0. So we'll have 2 sine squared x all over 2 sine x. Okay, then we can divide or cancel out the squared here. Then we cancel out sine x, and if we cancel out 2 So we'll have sine x. Okay, so number 2 is simply sine x. Okay, so let's continue. So we have the third example, sine 2x tan 2x times 1 minus tan squared x. Okay, so let's try. So we have sine 2x, so this is sine 2 sine x cos x. Okay, so using the double angle identity of sine. And for tan x, so we know that this is so times, we know that this is 2 tan x over 1 minus tan squared x. Okay, and then lastly we have 1 minus tan x. So we have times 1 minus tan squared x, sorry, tan squared x. Okay, so observe if we can cancel out anything. So we can actually cancel out the binomial, binomial 1 minus tan squared x. So we are left with 2 sine x cos x, 2 tan x. So let's combine. So 2 times 2, 2 times 2, we have 4. We have sine x cos x tan x. Okay, so this is not yet done because we know that tan x has its identity. So we have the quotient identity for tan x, which is sine x over cos x. So we have 4 sine x cos x. So this becomes times sine x over cos x. Okay, and we can actually cancel out cos x. And we're left with 4 sine x. Okay, or we combine this with 4 sine squared x. And this is our answer. Let's have example number 4. So for example number 4, we have sine 3x. Okay, so this is kind of a different from the last example. So what to do? So we can actually separate. Okay, so we have sine. Instead of 3x, let's have 2x plus x. Okay, because 3x is just 2x plus x. So now we have a double angle here, which is 2x, and a sum and difference. Okay, so this is actually a sum and difference identity. So we have sine 2x plus x, and this is actually sin cos cosine. So we have sine 2x, so we're going to use sin cos cosine, sin cos cosine. Okay, because it is sine. So sine 2x cos x plus cos 2x sine x. Okay, then we can further use further use the double angle here. So we have the double angles, sine 2x and cos 2x. So let's try to use the double angle. So for sine 2x, we have 2 sine x cos x. Then we have cos x here. So cos x plus for cos 2x. So let's use, so this is sine x. Let's use sine. Okay. In this scenario, the pair is sine. So let's just use sine. Okay. So we'll have 1 minus 2 sine squared x. Oh, no, let's not use sine. Let's use cosine. Okay, so what's the reason why cosine? You will know later. Okay, so we have 1. It's cosine 2 cosine squared x minus 1 times sine x. Okay, so then let's simplify further. So we have 2 sine x cos squared x plus, so distribute. So we have 2 sine x cos squared x minus sine x. Okay, so this is the reason why I used the second form of the cos 2x, this here, instead of the sine. The reason is because I want to combine these two. Okay, so we can actually combine it. So we have 2 plus 2. They are actually now similar terms. So 2 plus 2, we have 4 sine x cos squared x minus sine x. Okay, or we can have this as our answer, or if there we can factor out, we can still factor out sine x. So we'll have sine x times 4 cos squared x minus 1. Okay, so we have this as our final answer. Let's have example number 5. Okay, so for example number 5, we are asked to find a way to express this tan 2x over 2 into this. Okay, so instead of simplifying it, we are asked a specific form or specific identity. Okay, so let's start. So we know that tan 2x is equivalent to 2 tan x over we have 1 minus tan squared x all over 2. Okay, so from here, we have this here. Okay, then we know that if it's division, okay, so if it's division, we can express this one as tan x to tan x all over 1 minus tan squared x divided by 2. But if it's division, it becomes the reciprocal. Okay, so multiplication, then we have the reciprocal of the divisor. Okay, so here, it is already obvious that we can cancel out 2. Okay, so we are left with tan x over 1 minus tan squared x. Okay, but take note that our goal is to have this here. And observing the goal, we have a numerator equivalent to 1. So for us to have a denominator equivalent to 1, we are going to use concepts in our algebra. Okay, so remember, let's review a little bit. So remember that we can actually write this here. A is equivalent to 1 over 1 over A. Okay, so this is actually true if you try to, let's try to have a number. 2 is just the same as 1 divided by 1 half, or 1 over 1 half. Okay, so this is actually true. So we're going to apply it here. So we will transfer tan x in our denominator. So we will have 1 over 1 minus tan squared x over tan x. Okay, so since we have done that, we can actually continue here. I'll just use this one. Okay, so we can now operate in the denominator. So we have already 1 in the numerator. So denominator, we can separate. We have 1 over tan x minus tan squared x over tan x. Okay, and we can cancel out. So squared, we cancel out tan x. And then we'll have 1 all over. So take note, 1 over tan x is cotangent x minus tan x. And we have reached our goal. This is our answer. Okay, so we already, we have verified that this is correct. And that's the end of part 2 for my lesson. For the next portion, we will have the half angle identities.